Welcome back to Bristow Middle School Math. Our learning target today is when solving an equation, do I know how to find solutions and how the solution makes the equation true? So we want to know how the solution can make the equation true. And our learning targets, great vocab right here, inverse operations. Inverse, it's going to be a really important idea to understand what inverse means today. So part one, intro, solving addition equations. When you solve an equation, your goal is to get the variable alone on one side of the equal sign. So right now, when we look at this balance scale, the variable is x. We don't know what its worth is. We don't know how much that weight is, but it's not alone. There's something on this side of the equation, the scale with it. So the scale is balanced, and you can represent what is shown on the balance scale with the equation x plus 3 equals 6. But again, you'll notice that the x is not by itself, and we want to get it by itself. We want to isolate our variable. Notice what happens when you take away the same amount, 3 1 blocks from each side. So when we remove the 3 1 blocks from the left side here, it's now out of balance. This side is heavier because we removed 3 blocks from this side. But the idea in these scales is that we're keeping them balanced, and that's the same idea that we have in the equations. So once we remove 3 from this side as well, now it's balanced and our x is isolated. We isolated the variable, we have it by itself. So it's balanced again. In the equation, you can represent removing 3 1 blocks from each side of the scale by subtracting 3 from each side. So the solution to the equation is x equals 3. The value we give to the variable in this one is 3, and that's what's going to make the equation true, going back to our learning target. Let's look at an example. So here's our part 1 example. How many comic books do you need to add 17 comic books that you already own, to add to the 17 comic books you already own, to have a total of 30 comic books? So we're going to solve the equation. 17 plus x equals 30, which models this situation. We're going to let x represent the number of comic books that should be added to 17 comic books to get 30. You can use a model to find the value of x. So if we added 17 to x to get 30, then x would be equal to 13. Okay? So if there was 17 here with the x, there would be 30 on this side. We take 17 from here and we take 17 from here, we're left with 13 on the right and x isolated by itself on the left. X plus 17 equals 30, and the solution is x equals 13. So you have a total of 30 comic books. You need 13 more comic books. Now we're going to do a got it, solving our addition equations. So do this one in your notes and see if you can figure it out. We're going to solve the equation 8 plus x equals 36. So what would you do to balance this scale or balance this equation? We want to isolate the variable, isolate the x, and get it by itself, kind of on its own little island here. So we would have to take the 8 away from the left. And if we take 8 from the left, we have to take it from the right. How many are going to be left? Is it going to be 8, 28, 36, or 44? The correct answer is going to be 28. So if we had x plus 8, that would equal 36. If we take 8 from the left, then we take 8 from the right, take 8 from the left, 8 from the right, we're left with x equals 28. When we look at this, notice that it's like an array. We have 1, 2, 3, 4, 5 by 5. That's 25, 26, 27, 28. So the solution of the equation 8 plus x equals 36 is x equals 28. So key concept time. Inverse operations are operations that undo each other. Okay. Another way of saying inverse operations is to say opposite operations. So if we're looking at this, this is kind of our fact family here. 12 plus 4 equals 16. 16 minus 4 equals 12. So we can go around in circles all day long by doing inverse operations with the same numbers. If I did, if I add 4 to the 12, and then I take 4 from the 16, I get back to the 12. We get back to our starting point. Okay, so subtraction undoes addition. And then if we look at the opposite here, addition undoes subtraction. So if we go 16 minus 4 equals 12, we can add 4 to get back to the 16. Again, addition and subtraction are inverse operations or opposite operations. Inverse operations, this is our example, undo each other. So in our example here, inverse operations undo each other. Addition undoes subtraction, and subtraction undoes addition. Okay, subtraction is the operation shown here. So addition is its inverse operation. Okay, so we're going to show subtraction. So addition is going to be the inverse. On this problem, we would add 16 to both sides. On this problem, we would add 16 to both sides. On this problem, we would add 12 to both sides. On this problem, we would add 3 to both sides. On this problem, we would add 110 to both sides. How did I know which number each time? I was picking the number that was on the side of the equation that was with the variable. Here, the 16 is with the M, the 16 is with the P. The 12 is with the R, the 3 is with the D, the 110 is with the A. On this one, addition is shown here, so subtraction is the inverse. So we look, and we're going to do what? Subtract 7, because the 7 is on the side with the variable. We're going to subtract 100 from both sides. We're going to subtract 6 from both sides. We're going to subtract 17 from both sides. Let's look at our got it. Which equations, each equation shows an operation. For which equations is the addition the inverse operation? 1, b plus 27 equals 78. 2, 25 equals g minus 19. 3, 18 plus v equals 19. So let's look at that question one more time. For which equations is addition the inverse operation? The correct answer is only 2. Each equation shows an operation, which is the inverse operation or opposite. The equations b plus 27 equals 78 and 18 plus v equal 19. Those show addition, so the inverse operation is subtraction. The equation 25 equals g minus 19 shows subtraction, so the inverse operation is addition. Only 25 equals g minus 19 has the inverse operation of addition. Part 3 example, using those inverse operations to solve equations. Write a simpler equation equivalent to y minus 24 equals 57 to solve the original equation. We're going to use inverse operations. Y minus 24 equals 57. And remember, addition undoes subtraction. So to get the variable by itself, we're going to add 24 to each side. Y minus 24 plus 24 equals 57 plus 24. So see, we're doing the same things to both sides of the equation, just like we would do the same things to both sides of the scale. Minus 24 plus 24, that becomes what's called a zero pair. We take 24 away, we add 24, we're back at our starting point, which is 0. Y plus 0 equals 81 because 57 plus 24 was 81. Therefore, y equals 81. The identity property of addition is in play here. Any number plus 0 equals itself, and that includes variables. That's why the y plus 0 equals y. A simpler equivalent equation is y equals 81. Yes, this is still an equation because you have an equal sign and you have values on both sides of it. So check. We're going to substitute the value for y, 81, into the original equation and simplify it. So y minus 24 equals 57. 81 minus 24, does it equal 57? Use your calculator. Beep, beep, beep. 81 minus 24 is 57. And 57 does equal 57. Part 3, got it? Write a simpler equivalent equation to show d minus 29 equals 85. So remember, all of these are still equations. Some number minus 29 equals 85. So let's just kind of look. Okay, 29 minus 29, that's going to be 0. 56 minus 29, is that going to be a number bigger than 56? How about 85 minus 29? I mean, just by looking at our answer choices and being reasonable about it, I would say it has to be D. I haven't even figured it out yet, but let's try it. Bam. So writing a simpler equivalent equation to solve D minus 29 equals 85, use inverse operations, addition and subtraction. So D minus 29 equals 85, you're going to add 29 to both sides. So to get the variable by itself, you add 29 to both sides. Minus 29 plus 29 becomes 0. That's a 0 pair. 85 plus 29 is 114. Next line down, 114 is 114. D plus 0 is D, so D equals 114. The simpler equivalent equation is D equals 114. We would check that by substituting in that 114 for D and subtracting the 29. In summary, you can use inverse operations to solve an equation for the variable value that would make a true equation. Until next time, keep practicing because practice makes permanent.